Okay, my pre-calcers, those of you who have been watching closely, this is good old Mr. Cleefish's third video at this, and let's get her done. I'm going to try to save time, so I'm going to be breaking in and out, so here we go. Michael and Hannah went swimming in the sea at 10 a.m. So I've got my drawing already started. 10 a.m. Jasmine and Owen, I'll try to make a point that you want to make in a minute, but I'm sticking with this program. So it starts at 10, so 10 a.m. is the same thing as 0 hours. No time has gone by. So as you can see, we got 1 hour to, we'll have to convert this to time later on. But then it says it was at high tide. At that time, the height of the water was the same as Michael's height, which is 6 feet 1 inch. So 6 feet 1 inch. 1 inch is really not a number. We got to turn this into a number, so it's 6 1/12 feet, which is 6.083 feet. Now, this is not going to be to scale, so this might bother a lot of you, but I'm going to say that point right there is 6.083 feet. 0 time, the height is 6.083. So my y is my height. My x is my time. So we got to keep track of that. But let's keep going. It says at 1:30 p.m., so we got to do a little quick math. That's 3.5 hours. So we're going to go to here, and after 3.5 hours, so right there is 1:30 p.m., they decided to go swimming again. This time was at low tide, which was the same height of Hannah, which is 5 feet 3. So here comes 5 feet 3 inches, which is the same thing as 5 3/12, which is 1/425 feet. So this is what's going to bother some of you, but I want my curve to be very obvious and expanded. I'm going to put that height right there, 5.25 right there. But at 1:30, after 3.5 hours, that's where it is. So I'm going to make that point right there. So really the time that's gone by is 3.5 hours. And the height is 5.25. All right. Pause this just a second. All right, so here we go. So as we can see, we know we're talking about sinusoids, so we're going to do that, and we're going to say, wait a minute, we know a few things. Y is equal to cosine of x looks like this. Y equals sine of x. Let me make sure I'm on the, goes through the origin. So we're like, wait a minute, what's this looking like? So we're going to pick cosine and manipulate that. So I know right away we're going to have to build on our basic understanding of our cosine function, which is right here. So I'm not on the screen, but there we go. All right. So what am I saying right here? Well, half of the journey, half of the period is from here to here, because it took 3.5 hours to get from here to here, from high to low. So it's going to take another 3.5 hours to get from low to high, which is going to take us to 7. My drawing is not perfect, but there it is. Now, once we get here, everything seems to get moving. And I'm going to go ahead and we'll go ahead and read the first question. Write an equation to represent the situation. We've already gotten off to a good start. It's right here. I'm going to get rid of this, and we're going to talk about this. So we got to really look at this and analyze it. Well, where are we going to find the amplitude? Well, if you remember, back to our little baby cosine, we know that our amplitude of cosine is 1. We can look at above the x-axis, but we can also look below. Now here comes a big moment. So we know that the x-axis, I better use a better highlighter here. We know that the x-axis cuts cosine in half. I'm going to say that again because that's huge. The x-axis cuts our parent function in half. So when we insert this right here, that's my guesstimate at half. That's my new x-axis. Now this is huge. Everything's going to build from here. So I'm trying to find my amplitude. Well, up here is 1 or 1. Here, I'm from 6.083 to 5.25. Pause on that. All right, so again, high tide 6.083, low tide 5.25. I'm going to subtract because I want to know what this entire distance is, which is 0.833. But I only want to know half of that. So I'm going to take 0.833 divide by 2. I'm going to use my calculator, and I get 0.4165. So right here, 0.4165 is my amplitude. Now don't start rounding this too much because that's going to mess up our numbers, so be careful. So here we go. We're off to the races. 0.4165 cosine. Now we're going to find B, find C, find D. I'm going to talk about C right now. Notice the peak of cosine is right on the y-axis if it hasn't been shifted. And that's what we have going on right here. So I know that C is 0. In other words, it just disappears. Now what about D? Well, just so things play out, let's find B. If we look at this and we know that our period formula is 2 pi all over B, if we know what our period is, we can find B. And we do know what our period is. It's from 0. And again, I didn't label this, but this is 6.083, back to the high tide. So my whole period is 7. So I'm going to put that into this formula. So 7 equals 2 pi all over B. I'm going to multiply by B, multiply by B. So I get 7B is 2 pi. Divide by 7, divide by 7. I get B is 2 pi all over 7. So I'm going to put that in right there, 2 pi all over 7. We said C is 0, so it disappears. So there's my x. What's this D? Well, remember, my original x-axis cuts cosine in half. So we have to ask ourselves the question, how high did this go? Well, I'm going to bite it off into two pieces. We know that this amplitude is 0.4165, so we know this is 0.4165. Well, again, off scale, but this is 5.25 up, way off scale, so we've got to add this to this. And so here it comes. Let's see if the calculator shows up. 0.4165 plus 5.25. Enter. 5.6665. So, 5.6665. All right. Well, there is our answer for part A, because it says, write an equation to represent this situation. Now, the next question is, and this is where I screwed up the first video. It says, what was, that's in the past, the height of the sea at 5:30 a.m. So when I did it originally, I started moving forward and found out what it was. And at 5:30 a.m. the next day, might not, it's definitely not, because it's not on an interval of 6 hours or 12 hours or 24 hours. High tide, low tide's just way off. So we got to look at the past. There's two ways of doing this. We're going to do it mathematically here in 2 seconds. Give me a second. Okay, so we're up to part B. We got to really pay attention to this. What was? In my original video, for whatever reason, my brain just inserted the word is. I just instinctively thought about the future. So this is asking what was. Well, the original thought is the process begins at 10, but what was the height of the sea at 5:30 a.m.? So we need to think backwards and think, okay, how many hours prior to 10 a.m. is 5:30 a.m.? Well, if we look forward, that's 4.5 hours if we're looking from here to here. But backwards, we got to go back 4.5 hours. So with that being said, we're going to let x equal negative 4.5 hours. So we're going to get y equals, here it comes, 0.4165. I hope I left enough space. 2 pi over 7 times negative 4.5. I'm just going to leave it as a decimal. That's my x. plus 5.6665. I'm going to pause that a second. Actually, I better explain this. So as you can see, oh, I actually forgot cosine. So cosine is right there. So we got to figure out what this is. Now this is in radian form, so we got to make sure we take our calculator, because the whole thing would be a mess if we don't do this right now. Go to your mode, make sure you're in radians. See, mine would have been totally a mess. So now I can go cosine of 2. I would recommend use that pi symbol. It's going to be more accurate. And then divided by 7. Let's see. Here's what I'm going to do. Sorry, you guys. 2 times pi divided by 7 times negative 4.5. All right. So I know I need to find cosine, and I know this 0.4165 is in the front. I need to find cosine of negative 4.039 radians. So here we go. Cosine negative 4.039 radians. Enter. Times 0.4165. And so we get negative 0.2597 for all of this. But we need to add that to 5.6665. So plus 5.6665. And we get approximately, am I still on the screen? Yes. All right, we get approximately 5.4. Yeah, we could round that, but we're going to round that to 5.4 feet. Now, a little kind of a checkpoint. If this number is less than 5.25, you definitely did something wrong. If this number is greater than 6.083, you definitely did something wrong, because it's got to be fitting in here somewhere. So we're feeling pretty good about that. Now I'm going to hit pause and get ready for part C. All right, grand finale, part C. It says, when is the third time after midnight that the sea is 68 inches? So I'm going to get rid of this and just concentrate on this, and let's have a talk. So this is talking about the height. So they're really saying let the height, or y, equal 68 inches. Now we're not in terms of inches. We're always in terms of feet. So we're going to go 68 divided by 12. And that is 5.666, like 7 feet. So we're going to take this value and we're going to put it right here. Now what I want you to do for just a second is I'm going to put that in there. I'm going to go 5.6667. We got to use a little math instinct here and think about who made this math problem. A math person. And I want you guys to look. This is a close estimate. We round it a little bit. Same thing here. So, but what I'm going to say is these are so close that if we rounded, we would get 5.67 and 5.67, and we're going to make a dangerous but very likely assumption that these are the same. So if we subtract this from this side, subtract this from this side, we are going to get zeros. So mathematically speaking, 0.4165 cosine, and I'm going to go 2 pi over 7x, and this is no different than 2x equals 8. I would just divide by 2. I'm going to divide this by 0.4165, gone. Divide that by 0.4165, and watch what happens. 0 is cosine of 2 pi over 7x. Now, we got to use our thinker for a second. So what I'm going to do is I'm going to go back to the original y equals cosine x, and let's have a talk. The question is, when does cosine ever equal 0, question mark? Well, if we look at our parent function that we've been doing a lot, we would say, oh, it goes like this, and like this, this, and like this. This is my -1. Where does cosine equal 0? at 90 degrees. Now let's explain that. If I flip my spinner up to 90 degrees, there's my adjacent side, which is equal to 0. My spinner, we're calling 1. 0 over 1 is 0. You could also take your calculator and check that out. The point I'm trying to make is, where does cosine equal 0? It's where the cosine graph crosses the x-axis. Now let's apply that thought to this situation, because this situation comes from this story problem, which takes us back to this drawing. Here comes the grand finale. Originally, I drew in the x-axis right here, and we're saying, hey, so right there is where cosine equals 0. Right there is where cosine equals 0. But the wording of the question is, what is the third time after midnight? Now, my original drawing is a little confusing because I've got hours and I don't have time. I threw a little time there down. But to make our lives hopefully a little easier, what I'm saying is we're going to cover that up with this bad boy. Now, the thing I want to do is go back to where this is my x-axis, and I want to see if I can do a good job here, right down the middle. And what I'm saying is it's definitely at that height, 68 inches, every time it crosses our x-axis. So there's one, there's one, there's one, there's one, there's one, there's one. Now, we're going to have to do some thinking. So I'm giving you a visual presentation of what's going on, and I've changed this all down to time. So our brain has to work a little differently. So the question said, when is the third time? They're not talking hours, they're talking time. After midnight. Well, if we look, this whole experiment started at 10 a.m., and if I just fast forward it, and I get to 12 a.m., this is my midnight, but it's not, it wants the third time, and I can only, unfortunately, stuff in the second time. So, we know that it happens here, and we know that it happens here. Now, let me pause this for 2 seconds. All right, so for the grand finale, we're going to have to use a discussion about the period. Now remember, it goes from 0 to 7. So it takes 7 hours for it to go from high tide to low tide back to high tide. So that's one period. What I want to talk about is, how much time does it take to go half? Well, as you can see, from 0 to 3.5. But then, from here to here is our halfway point, so it takes 1.75 hours to get from our high tide to halfway. Now that's going to be important as we apply this to this picture here. So as you can see, we got 10.5 hours after 10 would take us to 8:30. Now that's important because 7 hours, well, what we could do here is just add, to get to this point, I just want to target this, which will help us target this, which will help us target this. I'm going to add 1.75 hours to 8:30. So that's 1 hour and 45 minutes to get to here. So that would take us to 9, that would be 10:15. So at that point right there, that would be 10:15. All right, I'm about 1,000% positive somebody could have done this way faster than I'm doing it. My drawing was a little off, but we should have been able to look at 12 a.m., that's 14 hours after this experiment started, at 12 a.m., and that's the whole target, how many times after midnight. So what we should do is say, when is the third time after midnight? Well, here's the first time, here's the second time, and what we could say is this is 1.75 hours, This is 1.75 hours. This is 1.75, 1.75, and that's going to come back. I know my drawing is a little crazy. 1.75. In other words, 3.5 plus 3.5, so 3.5 plus 3.5 plus 1.75. Now let me do the math real quick. All right, grand finale. So this 3.5 plus this 3.5 plus another 1.75 adds up to 8.75, which is 8 hours 45 minutes after midnight. So what is that? That's 8:45 a.m. Stick a fork in it. I think we did it. All right, like and subscribe. It's got to go viral. Thanks.